Okay, so finding the nth term of a sequence. Okay, and you might be unfamiliar with the word nth. Okay, now in mathematics we generally use the letter n for any number. Okay, so let's look at a sequence. So let's take a sequence, say 3, 5, 7 and 9. Okay, and this would go on. Now this is the first number in the sequence. This is the second number in the sequence. This is the third, and this will be the fourth. Okay, so this is what we call the first term of the sequence. This is the second term, the third term, fourth term, and so on. Now there are formulae for finding the nth term of a sequence, but for GCSE they keep it very simple. So I'm just going to show you a simple way of doing it, which is very acceptable and makes life very, very easy, and is also used on the BBC Bioscience site. So what I do is I look at the numbers and see if there's a common difference. So from 3 to 5 we have a difference of 2. From 5 to 7, again a difference of 2. From 7 to 9, a difference of 2. Okay, so we've got a constant difference of 2. So this is what we call a linear sequence. Whatever the difference is, I write down and I write n beside it. Okay, so this is 2n. Now n refers to the position number. Okay, so here n is 1, here n is 2, here n is 3, here n is 4. So we're using these numbers to find the numbers beneath. Okay, so if there was a common difference of 5, so we'd have 5, 5, 5, then this would be 5n. Okay, so I never use 1 and 2 because 1 and 2 have particular properties which other numbers don't have. Okay, they don't play fair. So I will always go to the third number, okay, which happens to be 7. Now here, remember n here is 1, n here is 2, n here is 3, and so on. So n here is 3. So 2n will be 2 lots of 3, which will be 6. But we want 7, so I'd need to add 1. Okay, now I can check this out. So if I go to the fourth position, now n here is 4, so 2n will be 2 times 4 is 8, and add 1 is 9, and indeed that's the number that we have. So this is the nth term of this sequence. So because we know n is the position number, we can now find out any number in the sequence without having to write everything out. So if they said, well, what's the 100th number in the sequence? Okay, or they say, well, what's the 100th term? So instead of writing this out 100 times, I can say, well, 100th term, n will be 100, because we want to know what number is under the 100th position. So n would be 100. So 2 times 100 is 200, plus 1 would be 201. I think this is quite a cool way of working things out. and making mathematics actually work for you. Okay, so let's do another one. So let's say we've got 5, 8, 11 and 14. Okay, now out of habit I tend to write 1, 2, 3 and 4. So this is my first term, second term, third term, fourth term. Now I find the difference. Now 5 to 8 is a difference of 3. 8 to 11, a difference of 3. 11 to 14, a difference of 3. So we've got a constant difference of 3. So that will be 3n. Now, as I said, I always go to position number 3. So if n is 3, 3n would be 3 lots of 3, which is 9. But we want 11, so I need to add 2. Okay? And I can check this. If n is 4, 3 4s are 12, plus 2 is 14, so I know that this is right. Okay, so let's give you one more. So let's say we've got -1, 3, 7, 7 and 11. So I write 1, 2, 3 and 4 above it. Now I look for a common difference. So -1 to 3, that will be a difference of 4. 3 to 7, again a difference of 4. 7 to 11, again a difference of 4. So we've got a constant difference of 4. So I can say here we have 4n. Now if I go to position number 3, if n is 3, 4 3s are 12, but we want 7. So this would be, if I had 12, I would have to subtract 5 to get 7, because 4 3s are 12, 12 minus 5 gives me 7. So if I check that with position 4, if n is 4, 4 4s are 16, 16 minus 5 does give me 11. So that's fine. Okay, nice and easy. So let's say, for example, that the numbers are going in the opposite direction. Now let's say we've got 9, 7, 5 and 3. Okay, so this is my first position, second position, third position, fourth position. So I look to see if there's a common difference. Now this time it's going down, so it's going down -2, going down -2, going down -2. So this is my common difference, so I have -2n. Okay, so if I go to position 3, if n is 3, now -2 times 3 will give me -6. But I want 5. So from -6 to 5 would mean that I'd have to add 11. Yeah, if I was £6 overdrawn and I wanted my account to be £5 in the black, I would have to put £11 into the account to make that so. So now I can check. So let's say I go to position number 4. Now if n is 4, that's minus 2 times 4, which is minus 8, plus 11. Minus 8 plus 11 does give me 3. So I know that this is the nth term for that sequence. Okay, so don't be afraid if the numbers go down. It just means that you'll get a negative value of n. Okay, but this would be the nth term for this sequence. Now occasionally you may get a sequence, for example 2, 5, 10, 17. Okay, so this is my first position, second, third and fourth. Okay, so I work out the differences. Okay, so here we have a difference of 3, here a difference of 5, here a difference of 7. So, oh dear, we don't have a common difference. Or we can get round that. We just go again. Okay, so here a difference of 2 and here a difference of 2. Now all this means is that because I've had to go twice to get a common difference, instead of 2n it will be n squared. Okay, so if you have to go twice to get a common difference and the common difference is 2, you'll get n squared. So don't panic, there's nothing to be afraid of. So now I always go to 3, as I said. So this time we're going to square it. So 3 squared is 9, we want 10, so I add 1. So if I check that, if n is 4, 4 squared is 16, plus 1 is 17, so that is the nth term of that sequence. Okay. Now, as I say, there are formulae for this, for both of these. There's a formula for linear sequences and there is a formula for quadratic sequences. Now, at GCSE, you'd have to know these off by heart. Now, I don't really feel that there's a need to do that. Examiners are quite happy with this method of finding the nth term. Okay, so you can practice this on your own, come up with your own numerical sequences. Usually in the exam it will be a linear sequence. Occasionally you get what we call a quadratic sequence because it's n squared. But you can see that the method is quite simple. Look for a common difference. If you don't get it, look again. Okay? So that's finding the nth term of a sequence. Nice and simple. Okay? So I will do nth term of a sequence part 2 just to show you an example or some examples of how they can give you an nth term and ask you to find the sequence.